So, ladies and gentlemen, there's a couple things we need to remember when adding complex numbers. First thing we can do is we can use the principal square root. That's why we wrote down in our notes the principal square root. We can use the principal square root to rewrite these, first of all. And I don't want to rewrite these with the negative square root because we can't take the negative square root of a number. So remember, the principal square root told us that we could take square root of negative 8, and we could rewrite that as 8 times negative 1, which we rewrite as 8 times square root of negative 1. And then remember, we talked about the definition of the square root of negative 1. We don't have that in the real number system, so we gave that to the imaginary number system, which we denote as I. Right? We don't have a number that is a square root of negative 1 in the real number system, so we say it's going to be in the imaginary number system, which we'll denote as I. So anytime you have a negative number, a radical square root of a negative number, we can really just write it as a square root of I, 8 times I. Right? OK, so let's first rewrite this whole problem. Negative 2 plus square root of 8I plus 5 minus the square root of 50I. Notice this is the square root of 8 times I, not the square root of 8I. All right. Now, ladies and gentlemen, when we're adding, we got to make sure we only add like terms. So I can only add the numbers to the numbers and the radicals to the radicals. That's all you can do. There's actually the formula. When you have complex numbers, you can only add a plus c and bi plus di, where you can only add the b and the d, which are their coefficients. All right? So I'm going to write the same thing. I'm going to write negative 2 plus 5. That's your a plus c. And then plus, we would like to write it square root of 8 plus the negative square root of 50 I. Because those are going to be your coefficients when you add them up. Does that make sense? Or you guys want me to write it a different way? I distribute it. So it's the same thing as square root of, it's the same thing as just saying square root of 8I minus square root of 50I. I'm just taking the coefficients and writing them together. So here, this one's easy. 3. However, square root of 8 minus square root of 50, you cannot tell me that's going to be square root of negative 42. You cannot do that. You have to get these to be like terms. So we have to go back to our mathematical brain and think, all right, how do I get these to be the same? Can I simplify these square roots? First of all, are they even square numbers? No. So I need to simplify these. So you got to go back and remember, how can I simplify the square root of 8? Well, remember, kind of using that principal square root property, I can rewrite this as square root of 4 times 2. Now I can take the square root of 4, which is 2, radical 2. Square root of 50 can be rewritten as a square root of 25 times 2, which is the square root of, it's 5 times the square root of 2. Did I see that? Now, what is this? 2 square root of 2 minus 5 square root of 2. Really, that's what you're doing. This is really, so it's plus 2 radical 2 minus 5 radical 2, I, which is negative 3 radical 2. So we can just say, instead of plus and negative, we can just say minus, and then I. Now we look at this. Is this in standard form? Is this in a plus bi form? And you can say yes. 3 is your a. Negative 3, or negative 3 times square root of 2 is your b, and I is your I. Where that's your real, that's your imaginary part. OK? Cool? Awesome.